So this is part 2 of the One Detect to Win. Again, just remember that all these webcasts will be in the SANS archive so that you can bring them up and see the series after the fact. Before we get started, I really quickly wanted to call out the Blue Team Summit in April. This is going to be the first Blue Team Summit event. It's going to be the inaugural event. That is all things Blue Team. It'll be the new release of the new SEC530 Defensible Security Architecture, and then obviously SEC555 will be there. So hopefully you are here for One Detect to Win Tactical Endpoint Detection. So this talk is going to be between myself, Justin Henderson, and Stephen Mathizer, who I have the privilege of joining us on this one. The one point I want to call out early on is that this webcast deals with using nothing but endpoint data to do really cool detection techniques. And on top of that, not only just endpoint data, it's basic endpoint data. We're going to run through a scenario that Stephen will introduce, that we're going to effectively use Windows or Linux logs to catch everything in the scenario. And that doesn't involve installing a whole bunch of extra software, security suites, antivirus, anything like that, because the logs that you can potentially get off a Windows and Linux box are actually quite good. So we're dealing with data on the endpoint rather than network data, which was the previous One Detect to Win series. So with that, my name is Justin Henderson. I am the author of SEC555 SIEM and Tactical Analytics, which is what this series is based on. I'm also the co-author of SEC455 SIEM Design and Implementation, and the co-author of SEC530 Defensible Security Architecture. So at this point, I really bleed blue. You should hopefully see that if you've been following the webcast we do. I'm a GSC, Cyber Guardian Red and Blue, and I have too many certifications to count. So with that, I'm going to tag off to Stephen.
All right, thanks, Justin. So I have a somewhat similar background. Started as a pen tester, still doing a lot of pen testing, but I'm finding a lot more of those engagements are turning into a how do we help to detect and stop me rather than how do I win as a pen tester. Being from Canada, I get asked to teach a few different classes. So I'm teaching in the incident response and pen test curriculums, as well as the Blue Team curriculum, and also ICS. I'm not quite up to Justin's level on the certs, but I'm working on it. So without further ado, we'll let you know that there will also be copies of these talks on, or these slides, sorry, on GitHub. But you will be able to log into the SANS website as well to get the archived webcast. So if you don't get this URL written down by the time I finish talking, you will be able to get it by going back and reviewing the webcast. So with endpoints, we have access to an awful lot of data. As Justin said, the trick is figuring out what's valuable to us and what isn't, because there is an awful lot of data out there. So what do we really want to focus on, and how can we use that data? If you've got any large organization, you've got probably enough data to fill up your SIM and then some. That's the most common complaint I hear from folks who are trying to pull in their endpoint data, is they just end up swimming in it. You know, even 10 megs per endpoint per day is going to generate an awful lot of data by the end of the day. And 10, you know, if you're getting 10, you're doing a pretty good job of paring it down. And then, of course, if you're paring your data down, you want to make sure you've got enough data to have the right data. And I guess, and that's the operative word there, is the right data. Because just volume doesn't help so much with detection. We want to have tactical data, or the right data, so that we have success at detecting attackers. So as Justin said, we are going to focus on endpoint logs exclusively for this webcast. And endpoint logs, you literally don't need anything else other than Windows event logs and event log forwarding to collect these things. There's obviously various collectors from various SIEMs and products and so on, but you can do all of this with just built-in Windows tools. So we're going to walk through a mock scenario here that follows this outline. So we're going to assume that somebody clicked on a link in a phishing email and that downloaded an HTA file, which is essentially a web page as an executable. We'll talk about that in a second. And then we're going to see our mock attacker escalate their privileges, add themselves to the administrators group, get some persistence by updating the registry, steal some credentials, and then try to pivot internally with those credentials and get access to more systems. Then they're going to go hunting for our data, which in this case is credit cards, which they will then compress and encrypt and exfiltrate back to wherever they are. And then finally, as a last step, they're going to clear their logs to cover their tracks. But they are going to be too late with that, as we are going to show you all the logs that they left along the way, because we're seeing them all in the SIEM. So first stage of our compromise is going to be the download of an HTA file. So there's a few ways that we can see this. We can see it using Sysmon, which for those not familiar is a tool from the Sysinternal suite, which is now owned and managed by Microsoft. And it gives you the ability to monitor just about everything you can think of on your endpoint, from file creation, open file execution, to the opening of network sockets, changing registry keys, process creation and process hierarchy. You can collect your hashes of any executable that's run, and you can choose how much of that data you want to collect and send it up to your SIEM. I don't think there's a link in here, but if you want to get an easy way to get started with Sysmon would be to just Google Swift on security and Sysmon, and you will find a pretty well documented Sysmon configuration file and a way to get started. There's more and more documentation popping up every month now as more people are using Sysmon. So we have installed Sysmon on our endpoints and are using it to generate logs. In this case, this log entry we see here, and most of these log entries, they are select lines from a log entry. You wouldn't see the same fields in precisely the same order necessarily. But we can see that Sysmon saw a file created. I used PowerShell Empire to create an HTA file because that was a nice, easy way to do it. And we can see that Internet Explorer is creating or writing that HTA file into its cache. So this is detected by Sysmon event ID 11. You could potentially catch something like this by turning on object auditing, which will generate events for anything you do that touches just about any aspect of Windows, in this case files. So you can catch this with object auditing, but you would be dealing with an awful lot of data doing that. So Sysmon is a cleaner way of doing it. So in this case, Internet Explorer downloaded the HTA. It might just as easily have come from Outlook. If the attachment wasn't blocked at the email gateway, then someone could get an HTA file in Outlook and either save it or double click on it there. Obviously, we want to block HTA files because they can be used to execute commands, and they really don't do, or they're not required. They're not used by a lot of applications or applications. There's no really good use for HTA files, so this probably should have been blocked before it got to the end user. But at least we can see, I would consider it notable that an HTA file showed up anywhere in my environment, to be honest. So then we're going to see MSHTA, which is the Windows executable that opens or processes HTA files. So we can see that mshta.exe was started. That's another red flag, because again, we shouldn't be seeing HTA files in our environment. And we saw that it got kicked off from Explorer. So it's not just from Internet Explorer, sorry. So it's not just, I suppose, on a corner case, you could have a developer creating an HTA file. We know that this happened through Internet Explorer. And we can see this in a couple of different ways. Again, sysmon is logging all of our file creation. The nice thing with both of these is again, we can see, or sorry, not file creation, process creation. In both cases here, we can see what the parent process was that started MSHTA, which was Internet Explorer. Even if you don't have sysmon, Windows now, as of Windows 7, I think, is logging or has the ability to log every single command as it's executed. To do that, though, you have to turn on advanced auditing for process creation. So it's not just a case of turning on your base level auditing, but in your group policy or your local policy, you have to go to advanced auditing, turn on detailed tracking for process creation. And so the first event that you see on the screen here is event ID 4688, which is Windows process creation. And the second one we see is from sysmon. In this case, we're getting pretty much the same information. Although I believe sysmon does give you a higher level of detail, a greater level of detail as to the actual command line parameters and other things that went into the actual starting of the executable. So we can see from here that we had an HTA, the MSHTA executable ran, opened the HTA file, and as I said, you almost never need to do this. And if for whatever reason you have a need to do this in your organization, then figure out what that is and just exclude those logs, whitelist it so we don't see those logs, because you still probably care if somebody is opening HTA files. And then you really care if you see something like MSHTA starting PowerShell. So again, same detection here. We're using event ID 4688 and sysmon to catch PowerShell executing. And in this case, there's a few things that we should be concerned about. Number one, that MSHTA has started PowerShell. That's probably not a good thing. And the second thing is that it is starting PowerShell with an encoded command line. So the command line is rather long and is base 64 encoded. And again, maybe that happens in your environment, but it happens, the most frequent place that happens or time that happens is when malware is running. So, a long command line, an encoded command line to PowerShell, those are big red flags. We don't have the screenshots in here, but you would also see PowerShell logs. Well, PowerShell can create its own logs, especially the newer versions of PowerShell. So version 4 or 5. We're up to 6.0 now, I think. So you should be running PowerShell 5 at a minimum on all of your endpoints, and hopefully PowerShell 2 is actually removed, so it can't be run. And then you can turn on PowerShell logging as well, and you would see this command line, and you would actually see you would see this deobfuscated or decoded, and you would see all of the modules that PowerShell is actually running as well if you have the PowerShell logging going back to your SIEM. And yes, that can be verbose, but 99% of the people in your organization are probably not running PowerShell on a daily basis. There's going to be some who will generate a ton of output, but the majority are not. So it's still very much manageable. So we saw MSHTA.exe starting PowerShell. That is not a good thing. Another really, really simple indicator of compromise is the creation of a new service. New services are good because they give us an opportunity to maintain persistence, and they also give us an opportunity to execute code as the local system user. It's an easy way to run code as system. In this case, we can see 3 different services being installed on the system in question. The bottom one itself doesn't look that bad at a first glance, other than a 10100 USB NIC is probably not that common these days with a 32-bit driver, and that is actually a bash bunny from Hack5. pretending to be a network driver and establishing some persistence for itself. So again, there's a lot that we can get with new service creation, because honestly, especially if your users don't have the ability to install software and install services, which they shouldn't, you're not going to see a lot of service creation other than when systems are being built. It happens, to be sure, but again, system or service creation, brand new services appearing, shouldn't happen unless software is being installed, basically. And there are two very, very common attack techniques that create services. One of those is Metasploit, and the other is PSExec and Metasploit using PSExec for that matter. And one of the hallmarks for Metasploit running PSExec is it creates a service with a random name, like you can see here, the PWBK whatever. That does not look like a normal service name at all, and that's something we can look for. So there is a tool called freak.py that was written by Mark Baggett, who's also a SANS instructor. And that is something that you can integrate with your SIEM or with your processes that will basically do a frequency analysis of any string. So you give it a dictionary that says normal service names look like this, and it will tell you that this does not look like a normal service name because it's purely random. It's not an English word. So either way, again, we have a service that's being installed with a random name, and it too is running PowerShell. Services that run PowerShell directly or cmd.exe are not typical. Another one, again, depending on how you manage your environment, would be PSExec itself, because that also creates a service called PSExe SVC. So unless you routinely use PSExec to manage your environment, I would suggest there's better ways to do that with PowerShell. Then the PSExec service getting created is a big red flag as well. And then if you look at the bottom event, we see a different service that is being used to run command.exe and send its output to a pipe. So this is our privilege escalation through a named pipe. Again, it's a random service name. The service that is running, or the command that's being run by the service, is command.exe, and it's using a named pipe. None of those things is typical of a service. So this gives us a lot of really good indicators, tactical information that will allow us to detect privilege escalation and detect a bad guy. And again, this is simply from service creation, one of the basic events that we get from Windows. Now, establishing persistence, because after all, what good would compromising somebody be if we don't actually maintain our persistence? So there's some really easy ways to do this. One is to create a new scheduled task, and the other is to update the registry. So we don't see the scheduled task here, but we do see the registry change to the current version, I'm assuming run once, reg key. So sysmon does a great job of picking up any activity in the registry. You can't monitor the whole registry, but you can certainly, because that is going on constantly, or registry access is going on constantly, but you can certainly monitor the registry keys that are commonly used for persistence, like the run once keys. So here we're seeing, again, what user is being used. Or is that, sorry, that's our domain and our user, yep. And we are seeing an object or a key called ownage that is going to run a batch file every time Windows starts, so that our attacker can maintain persistence. That is event 4657, which you can also get out of sysmon. And event 4698 would be the creation of a new service. So in either case, you want to be watching for those things as indicators that somebody is obtaining or trying to maintain their persistence. And again, those things do not typically happen, especially on workstations, on endpoints. There are very few users out there adding scheduled tasks, and very little software that is out there adding scheduled tasks outside of the installation of software. which should be managed centrally. Can you advance that slide, Justin? It didn't go for me there. There we go. And probably the most common way of maintaining persistence is adding users. So those are very, very easy to detect with vanilla Windows events, both at the domain and the local level. And realistically, you can see who is creating users. So you should have an idea of who should be creating users, what their process is around it, where they should be logged in when they're creating those users, all those things. So you should be able to whitelist normal activity. And realistically, you probably want to know any time a user is created as a member of an administrative group. Bottom line is local accounts don't get added. Domain admins, enterprise admins, local admins also don't get added on a regular basis. And those are one of the biggest hallmarks of an attacker being in the environment. When I'm doing a pen test, I typically add users in all of these places to see what happens, see if anyone notices. If nobody notices, then I know I can just about do anything I want on that engagement because no one's watching. And of course, one thing that most attackers do in some form when they log in or when they gain access to a system, they want to elevate their privileges. So I've got a user, they've clicked on a phishing link, they've downloaded an HTA file, they've executed that HTA file, and I've got some sort of backdoor, some sort of command and control, but I'm still logged in as that user. The next thing I want to do is become a domain admin or get some form of administrative access. In order to do that, I'm going to want to figure out who is a domain administrator. To do that, I'm going to query the domain admins group. So this is one of the best use cases for object auditing, is to turn on object auditing just on that domain admins group. So you can create an ACL on the group that basically says, I want to audit when anybody reads the members of this group. And it's this group in particular, or your privileged groups, your enterprise admins, domain admins, and so on, that we're interested in. So we can get notified when anyone even queries that group, because it really doesn't happen that much. And if you have products, any number of products, whether they're for access management or remote access or whatever, that do routinely query domain admins, then it's very easy to whitelist those, because you know exactly what that is, where it's coming from, what the signature of that event basically is. So there's probably some whitelisting involved when you turn on the object auditing, but then as soon as an attacker even looks at your domain admins group, you are being notified of it. And he pretty much has to look at it. The nice thing about this technique is we're not trapping the command line or catching the command line of someone running net user/domain. But no matter how they access that domain admins group, whether it's PowerShell or WMI or just a regular command line, we're getting an event saying that someone accessed the domain admins group, and that is 4662. Locally, this isn't quite as easy, but we can do a few things. Especially because most attackers are not really thinking that that there's anyone looking for these indicators, or that there's anyone even logging local access on a workstation. So a lot of times, I've done a number of engagements where we've tuned a SIEM, and we're literally just looking for net local group administrators, and we catch attackers just based on that string. Can they find out who else is in the local administrators group, or who is in the local administrators group without running that local group administrators? Sure, they can, but they have to decide to do that. They have to think they're being watched and try to work around that. And if they are going to try to work around this kind of detection, they're going to have to do something else to do it, which we also might detect, whether it's a long command line, weird characters in the command line, accessing WMI from the command line, again, not something that happens very often. So sure, you can bypass this detection, but you're probably going to be going to a lot of work to do that. And this is pretty much, whether it's domain admins or local admins, those are pretty much the things that you're going to do as an attacker as soon as you land, because you need to elevate your privileges. So in this case, for domain admins, we are logging access to the object. So somebody actually just read the object in any form. There is no ability to do that on a local workstation natively in Windows, but command line logging. So good old event 4688 or sysmon can tell us as soon as someone has queried the local administrators group using a command line tool anyways. So at this point, we've got an attacker who's had us click on a phishing link, which was a malicious HTA file. We've executed that HTA file, obtained some persistence either through a scheduled task or through modifying the registry. We've elevated our permissions through a named pipe, and we've started looking around for other administrative accounts that we could potentially compromise. And so with that, I will turn it over to Justin and let him continue from there.
All right, thank you, Stephen. So at this point, again, we've used nothing but Windows logs really at this point. So let's assume we've got the initial box compromised, but now they want to move to the next system. Typically when this happens, you're either using stolen credentials. My favorite is always doing something really stupid, like setting the screensaver to a minute. Because what happens? End user gets annoyed, they call the help desk. Help desk remotes onto the box. Well, depending on how they remote on the box, those credentials can be stolen and then reused. Like it's literally that simple. There's like 3+ ways to steal credentials. Well, there's a lot more than that. There's 3 ridiculously easy ways to do it. Service accounts, if they're on the box, if there's some type of special thing that you go under services.msc and you list out and you find a special service account, you can dump those out of the LSAS. Like it's crazy simple to steal credentials, which means from an endpoint standing, we should be looking for stolen credentials. Well, how do you do that when logons are used all day long? Well, you look at event ID 4624. That's the logon success event ID. Logon success, not logon failure. And what I'm looking for is attempts to use accounts in ways they were not intended to be used. So as an example, let's say an IT person logs onto that system's box. I set the screensaver to 1 minute. They fix the issue, but now all of a sudden you see a bunch of 4624 events from that IT user from the desktop, say it's an HR desktop, and it's reaching out across the network to a bunch of systems. That's weird. I mean, yeah, maybe they're reaching out to a shared file server where IT files are on, but you're seeing now that user being used to servers, other desktops. Like, that's weird behavior. You shouldn't see that. Even something like event ID 5140, you're seeing standard user accounts trying to connect to admin shares, simulating TSXX behavior. So even though we have logon type events, how they occur matters. The logon type, I'm just kind of highlighting this real quick. There are multiple logon types. You log into a file server, it didn't prompt you for username and password, the network logon. You log on at the keyboard and mouse, that's an interactive logon, which means you have full-on controls and the credentials can be reused across the network. So that matters as well. So, all right, how about this? End users trying to log into a bunch of systems and it keeps failing. Okay, that's boring. I mean, come on. Brute force attacks, yes. Obviously, if you're seeing a bunch of failed logons, look for it. Every SIEM comes with that rule by default. That's cute. What about too many logons? This is an area that I actually think is more important. Externally, if you have an external facing service like Outlook Web Access, VPN, whatever, you might see a bunch of failed logons. You're being brute forced, server-side attack. On the inside, if I steal credentials, yes, I might get failed logons, but a lot of times they're going to work. Like, if I steal an IT staff's credentials and I go to turn around and use them, a lot of times they work. However, if I'm crawling the network, like in this scenario, we're looking for credit cards. As the attacker, I'm crawling your network looking for where you're storing credit card files. You're going to see a bunch of successful logons that are going in a direction that's odd, say HR desktop to a bunch of servers, bunch of desktops, and just the volume of logons is really weird. Even whether it's interactive or network-based logons, the count is abnormal. So running scripts or even manually, if you see a bunch of logons to different assets within a given day, that's odd behavior. So I like to hone in on too many logons because people just don't really look at that much. Now, going back to direction though, if I steal a service account and I'm on an endpoint, let's say I'm doing a trick where you can steal vulnerability scan credentials, assuming your settings aren't tuned properly. And I turn around and I use the vulnerability scanner credentials. How many successful logons do you need to detect that? 1. Because again, directionality. You shouldn't see service accounts, especially like the vulnerability scanner account, coming from a desktop. And your SIEM is very good at distinguishing direction in the logs. So again, apply these. This is a little bit of know thy environment, but the logs are there for you to use. A more kind of applied approach to directionality that I really like is if you know you have sensitive users. And here I'm going to call out domain admins, but I want to clarify this. I'm really talking sensitive users. Like you have something that's either it's domain admin, so if the account gets compromised, they have company-wide access. Maybe you just have systems that are so sensitive in nature, you need to add a few hoops to jump through. Then I like to do what I call controlled authentication. This is implementing things in a way that certain accounts can only be used from a specific directionality. So in this picture, we're forcing the use of a domain admin account through some form of jump box, whether that's a VDI, virtual desktop system, a remote desktop system, maybe it's another physical box, but whatever it is, we're now stating if I see any of these domain admin accounts used, it better be from the jump box network or subnet. If it's not, oh mama, that's bad, all right? So this is fairly easy to implement, and really we're just taking advantage of the directionality of logon success and logon failure events. But it makes it really easy. This is basically architecting your environment for detection specifically. And you might have prevention in there too if firewalls are in the middle. But from a detection standpoint, man, this is great. It's great and it's easy. All right, let's do some more tactical endpoint logging. If you know MC Hammer, you've heard the song, Can't Touch This, nah, 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 nah. This is one of my favorite techniques. This is by far one of my favorite techniques. This is using the concept of a honey token. So let me just run through this and I'll back up. Let's assume I'm using group policy. And I create a group policy that says put a file on the C drive in a folder called hidden, and we'll call it passwords.txt or creditcards.csv or employee salaries.xlsx. And to be honest, I don't care if this is a hidden folder or a not hidden folder. I'm showing that in the pictures, but it really doesn't matter. And I put the files there, and also with the same group policy, I turn on auditing. So anytime this file, or folder really for that matter if you want to go there, anytime it's touched, read, listed folder contents, anything like that, event ID 4663 generates. Now, let's back up. What does that give me? That gives me the capability that if anybody runs any sort of automated tool or manual scan, like they manually crawl the folder or search the hard drive, I've got them. Because what you do is you tell your antivirus, hey, leave that folder alone. These are not the droids you're looking for, right? Everything, leave this alone. And even if your software ignores it, because antivirus, even though it's supposed to have exceptions, it'll ignore it, you tell your SIEM that if it's from this processor or user, ignore it. Now, if it's from anything else, can't touch this, right? This is so freaking awesome. Like, because as an adversary, how would you know this is in place? How would you know what folder it's in? You could try to crawl the group policies, but you have to do that first to figure this out, and that assumes it came from group policy and not your asset management system. So you could do this with a group policy. You could do a different set of files with your asset management system, and unless you have some of the most hardcore pen testers or adversaries in the world, they might trip one of these files. Because it doesn't matter if they're scanning your local system or they're remotely scanning other systems, because in 15 minutes, you can deploy this to every single Windows system in your environment. Okay, I'm pausing for dramatic effect here. I can't see you guys, but hopefully they're like, oh yeah, dang, Justin, that's freaking awesome. Because it is. It's that cool. Now, this technique's so cool, I'm going to call it out on Linux too. So on Linux, if you install Audity, which it comes in some distros, a lot of them, you just apt-get install, yum install Audity, boom. At the bottom, with the sections that have bold, you create rules like this. /etc credit cards.csv or etc password. You give it the permissions that you want to monitor, and you give it a keyword that you want to show up in the logs. So in this one, I put no touch ECCs, so no touching my credit cards, no touching my password D. And now you have logs for that as well. So the same technique can be applied across multiple systems. So that's a really powerful one. Don't underestimate that one. Okay, the other one that's really cool that I feel is highly underrated is your host-based firewall logs. Windows has Windows Firewall with advanced security. It's now Windows Defender something or another. It's really close to that still anyway. I don't care if you're using Windows Firewall or you have a endpoint suite that has a firewall. The logs from your firewall are really cool because they're not just IP, source test, block, allow. No. It's a host-based firewall, which means you now have processes. You have this process along with this network information was allowed or denied. So for example, in this is just a basic NTPD, so it's a network time protocol daemon. It's an agent. And it's saying something tried to connect to me for some reason. I don't know why, and I blocked it. Now, this is inbound and outbound and listening. So think about this for a second. If in your environment, Windows Firewall cut a log saying Windows PowerShell connected out to the internet, would that bother you? How about this one? How about Windows PowerShell is listening on a port? If that bothers you, pick up the logs and figure out where, why, and what. Okay, well, then you have the concept of, wait a minute, Justin, you are freaking crazy and nuts. Both are true. Well, it's very much true. Okay, that's too much data to collect. My argument to that is no, it's not. No, it is not. I've had this in small organizations. I've had this in large organizations. What it's telling me is that you haven't started doing this so that you can fix all the issues that you'll find with this. For example, there's about 5 key settings in Windows that if you don't turn them off, you're having things that'll broadcast or multicast all day long, and that's what's filling your logs. So by monitoring these events, finding out what those are and fixing them, your network will thank you, your logs will thank you, and now you have a tactical detection events that are freaking awesome. Okay? Now, in this webcast, we didn't go very far into filtering or collection strategies. We have other webcasts that we've previously done that go into that, so I don't want to spend time on that. But all of these are areas where you can even say, don't send the log over unless it meets the criteria I care about. Okay? So host-based firewall logs are sexy. Okay? You just got to get them there. In our scenario, we also have the compression and encryption. And while this sounds really, it seems like this should be far-fetched, that an adversary would download tools like RAR or 7-zip and WinRAR or all these different executables to do compression and encryption. You would think they don't do that. Yet if you read through like the Mandate APT reports, or if you go through different malware samples you can find online, or, I don't know, if you're in a business that's getting attacked, you probably will see this. So again, we have command line process creation events in event ID 4688. We have sysmon1. We have AppLocker, which is Windows application whitelisting. All of these can catch these abnormal utilities on boxes that are not authorized. Now, pointing out here in these pictures, you'll also notice that they're in user land. They're in the C users username folders, because oftentimes the malware gets on a box and it's working within those user directories, especially if you don't have your end users as administrators. So you can hone in on, rather than just looking for everything, I just want to look in the user land folder. What's going on in there, and I'll hone in more on that. So this just, for some reason, does happen a lot. So, and then of course, clearing the logs. Oh, I'm a bad guy, I'm going to hide my tracks, right click or command line or PowerShell, clear the logs, woohoo, haha, neener, neener, you're not going to catch me. Except if we're doing SIM-based logging and we have a log agent, or we're using Windows Event Forwarding, the logs have already been off the box before they cleared them. So one, that's cool. And two, now that the fact that they did clear the logs is like a huge red flag of, hey, look at me. Because why are you clearing logs on a desktop? Why are you clearing logs on a server? Now, on a server, maybe because you might have the policy that says if it gets too full, crash the box. In which case, if it gets close to full, someone might clear them. Okay, SIM's still really good at making exceptions. But on a desktop, really? Shouldn't those just auto-rotate and age out? So now here we have event ID 104, 1102. To be honest, there's multiple log event clearing ones because there's actually a heck of a lot more logs than application system and security. But again, them clearing it, huge way to find something abnormal is going on. All right. Now, at this point, we've effectively finished the scenario. And every single step in that scenario, we were able to identify things. So we had, I'm actually just going to go back to that real quick. So in this scenario, we've got initial compromise. We saw the HTA. Privilege escalation. We saw the name pipe. We saw the new service creation. We saw PowerShell being invoked. We saw new local accounts. We've got the administrator group. That was easy. Persistence via reboot registry key. That's cute. We could have caught it if it was a new service. Technically, there's other techniques we could see if it was a driver, whatever. Again, this is just an hour presentation, and I'm trying to make sure you have room for questions and answers here in a second. Credentials stolen. It's a little hard to see credentials being stolen, the act of them being stolen, but how they're used tends to be easier to detect, and we honed in on that. We've got crawling systems with the credit cards. They can't touch this, right? We can do things like that. It's super awesome, super effective. And then, of course, how they're exfiltrating the data. Didn't focus in on network because this one is more on endpoint data. You technically could do network-based exfiltration detection via sysmon event ID 3, which is network events with processes associated with it, which is really cool. And then logs cleared. Now, if you've heard this whole scenario and you're still itching for more ways to catch things with endpoints, I want to call out, first off, our previous webcast. There's the Windows PowerShell detection webcast, which was super awesome, and it honed in on PowerShell logs and how to do some pretty cool advanced detections with those special PowerShell logs. Almost all the logs we talked about today were application system or security. We talked also about sysmon, but everything we showed could actually be caught with application system and security. There's actually many, 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 many more Windows logs, Windows channels. Windows driver framework can catch USB insertions, removals, things like that. So there's many more different things we can use from a log perspective, but we're already just touching the surface of what Windows and Linux is capable of doing. The Sigma project is not actually a rule set project, but they just happen to have a lot of really awesome Windows or Sysmon rules baked into it. Sigma I'm highlighting because it's a generic signature format for SIMs, where we can write a rule and then convert it into an alert for Elasticsearch, maybe an alert for Splunk, maybe an alert for insert SIM product here, so that we can start sharing these rules. And that's why there's a pretty good default rule set as well. Also, you can check out the MITRE attack framework. That also has a really good list of things to look for. So we can keep going with this. At the end of the day, if you're listening to all this and you're thinking, holy crap, that's really cool that you can detect all that with Windows logs, you might want to look into SEC555. Or maybe you're thinking a little bit more on the pessimistic side. Justin, Steven, that's great. But again, you're freaking crazy nuts because it's too much data. Again, we didn't focus on this in this webcast. There's a SIM design and implementation webcast that might be good for you to watch for this. There's a heck of a lot of filtering and alert techniques we can do to severely minimize what gets sent to your SIM. Like Windows logs could shrink by 80 to 90% using certain techniques. New service creation, we could do a whitelist approach that unless it's a service that's never been seen before, it doesn't even make it to your SIM, right? So there's some really cool techniques that we can help from the logistical side of pulling off this tactical data. The key, though, is it's not the SIM that makes this all work, it's you. And that's why SEC555 SIEM and Tactical Analytics is so important, because it focuses on training you in a structured format, 6 days with boot camp. So with that, I want to go ahead and open the floor for questions and answers. And for this, if you would, just put questions in the chat window. I think I always say the chat window, and it's not actually the chat window.
Yeah, it's the questions window.
The questions window. And then Stephen and I'd be glad to take some questions.
All right, thank you both for that great presentation. As Justin was saying, we do have a couple questions ready for the Q&A. However, if anyone has a question, please enter it into the questions window. There's a question here, Justin, that I'm going to actually assign to you so you can see it. But I'm not going to start with this one because I think I'm going to have you read the one that I'm sending you. Okay. The first question will be, what are the 5 key settings?
The 5 key things?
5 key settings.
That question might be a little too broad. Can you be a little bit more specific on what you're looking for? Are you looking for group policy audit settings, or? Yeah,
so if Bobby, you submitted it, if you could please clarify that question, that'd be great. Justin, I don't know if you had a chance to see that one. It says, would there be similar logs if a malicious document was received that utilizes mshta.exe, such as, and then he goes on to list some commands.
I can't see the command for some reason in the chat window.
Okay.
But if whether it's being invoked from like a Word document using a macro, maybe an Office document using a DDE, which bypasses macros, it doesn't matter because the process creation events, they get generated at runtime. So you might miss the parent that called MSHTA, but you'll see it, whether that's sysmod event ID 1 or 4688 from Microsoft.
All right, thanks, Justin. A couple other attendees clarified. You mentioned 5 key settings during your slides. Someone says, Justin mentioned there were 5 key settings that filled logs. Does that help?
5 key settings that filled logs.
If not, we can move on to the next one.
Yeah, I'm going brain dead on that. Sometimes I say stuff and I have no freaking clue what I'm saying. I'm just full of it. No.
All right. How about, is there an event ID that would detect a tool like Responder?
So a responder is going to be like the Hack5 Bash Bunny pulling out credentials. It depends on how you're invoking it. Like, for instance, if I plug a Bash Bunny in or a land turtle and I'm running responder through that way to do like the Mubix attack to steal credentials from a Windows 10 box that's locked, you're going to see things even like that new service creation where we pointed out the real tech. That's going to show the device appearing. You might not see like the man in the middle directly, although if you're doing sysmon, event ID 3 is probably going to point out some weird stuff. This is also where, like, when I'm writing or testing detection techniques for 555, I have a full lab of lots of VMs collecting logs, and I'll simulate the attacks and do a before and after. So you definitely can see it. I just don't know the list of different event IDs you're going to see. Other than I know you're going to see, if you did it with a physical device, you're going to see that show up somewhere.
All right, thanks. All right, we're going to try one more time. What are the 5 key settings in Windows that we should be doing on computers in Win 10? And the original person who asked the question said, settings that can reduce multicast and broadcast and host-based.
Oh, yes. Yes. Okay. Off the top of my head, LLMNR resolution lookups need to be disabled. NetBIOS, if you can. Some legacy applications need it, but in 2018, hopefully you can get rid of it. What are the other ones on that? Let's see here.
If you actually
there is
Google
Yeah, go for it, Stephen.
If you search for article number 3299 on adsecurity.org, there is a very, very detailed list of all of the things that you should be turning off.
Thank you, Stephen.
And we can find that link. Actually, I'll see if I can find it here and put it into the chat.
Yeah, the 3 biggest are NetBIOS, LMNR, and SSDP. But there's other ones like Google, Dropbox, all those sorts of things. You can shut that crap off, and your host-based firewall will thank you for that.
All right, so Stephen, go ahead and send that link to me, and I'll send it to the group. All right, next question. Is there certain services or processes that should be a red flag for sure when running?
Yes. But so here's kind of a difference. If you do it directly off processes running, like for an example, if I saw mimikatz.exe, that's a huge red flag. If I saw PowerShell invoking Empire, like Stephen ran earlier, that would be on one command, one process creation event. That would be a red flag. While that works, again, I could rename files, I could rename processes. It's still great. Blacklisting is not dead. Blacklisting is still a good thing. But a lot of these, what I like to try to do is use the SIM as a whitelist. Basically dump out what you know about, use it as a whitelist, even if there might be malware in it. And now just look at the new things, like new service creation. Again, if I saw a random named process for the service, that's a red flag like we showed in the slide. But when I'm actually implementing that technique, I'm just looking for a process I've never seen before associated with the new service event. So you kind of want a right mix of blacklisting and whitelisting. And the SIM makes whitelisting really easy.
All right, this next one, I'm going to read it exactly as it's written. Small businesses, dash, now funds to purchase a SIM, dash, how to manage?
So I love that question. Thank you. SIMs are expensive, and no matter what you're doing, whether it's an open source Elastic solution or a commercial Splunk ArcSight logarithm, whatever, the biggest thing you just got to keep in mind, there's a pretty decent labor commitment. If you're a one-man shop and you buy a SIM in a small environment, expect that a third to half of your day is now dedicated to that SIM, if you actually want to use it appropriately. So it's less about the tool and more about the people you're going to be assigning to the tool, which is why 555 is SIM agnostic. Now, if you're trying to cut the budget and cut the bank and save money, I recommend looking at SEC555, SIM design and implementation. For a small organization, you'll save thousands, tens of thousands of dollars, because by the end of 2 days, you actually roll your own SIEM and know how to do it.
All right, thanks. This next one, I'm not sure if it's asking you something you can't answer, but I'll throw it out there. Do you have any tool suggestions for containerized Linux environments that are like Sysmon or other good Linux-specific resources?
So there's OS Query, but that's not like Sysmon. Audity is probably the closest to Sysmon. The problem is Audity can get way more granular, which actually makes it a lot more unwieldy to use, and the documentation is not as nice. But for an apples to apples, it'd be more of Sysmon versus Audity. OS Query works across all, but it's more of a pull rather than a generate event. Other than that, there's not really a Sysmon for Linux that I'm aware of anyway. Stephen, you know of any?
No, I mean, you can get the information with something like strace or I forget what the other versions, Trust, I guess, was the old Solaris one, or AIX. But again, it's something, they're extremely noisy. It's more like running Procmon and trying to get logs out of that. So you would have to do some significant work to filter that down.
All right, the attendee says thanks, that helps. One last question. Hi, what is the recommended size or duration for logs?
The recommended size or duration for logs. I'm assuming you're referring to the Windows log. And Microsoft has some best practices you can find under the Center for Internet Security Benchmarks. Doesn't mean you have to use that setting. As an example, on a Windows desktop, I might set it to 80 gig per like for instance, application system security. But on a server, I might crank that up quite a bit. But the Center for Internet Security has some really great logging best practices around Microsoft platforms. That would probably better answer that question for you.
All right, that's all the questions.
One thing I'd say too, sorry, is when I'm doing incident response, the thing I hate the most is showing up and finding that the most recent logs were 5 minutes before I arrived, or sorry, the oldest logs were 5 minutes before I arrived on site. So even if you're not looking at your logs, which obviously we strongly recommend, even having a week or so, setting your threshold so that you have a week or so worth of logs, at least you're then in a position to triage what's going on in a major event.
Yeah, I err on the side of cranking it up, because you're not going to have a performance issue on your endpoints or servers by allowing longer term storage on your endpoints.
All right, we had one more question come in. How about a large amount of SVC host identification that may be running?
So anything that's related to built-in Microsoft processes like SVC Host, I'm going to point you to the defer poster of, what's it called? Stephen, interrupt me if you know it. I think it's one of the malware can run, but it can't hide posters. And it goes through and talks about all the key Microsoft processes like SVC Hosts, LSAS, and it'll say it should only be running from this parent program and it should only spawn this many instances. You can use that poster to implement alerts and find things that are breaking how Microsoft expects those known common processes to execute. And that's actually a great idea.
All right, he says thank you. Well, that's all the time we have for today. Thank you so much, Justin and Stephen, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.